Diacetyl is most commonly described as buttery, butterscotch, or buttered movie theater popcorn. Diacetyl changes the mouthfeel of beer. It produces a slick, mouth-coating sensation and makes the beer more satiating. The issue of whether diacetyl is an off flavor primarily depends on whether it's intended to be in the finished beer. In some styles, small amounts of diacetyl work well, but most styles feature little or no perceivable amounts. Beer competition guidelines tend to indicate which styles allow perceivable levels, but in every allowable case, only small amounts are permissible. Diacetyl is produced during fermentation as a byproduct of the synthesis of the amino acid valine. During the synthesis of valine, one of the intermediate products is a compound called alpha-acetolactate, the precursor of diacetyl. This compound leaks out of the cell during fermentation, where it's converted to diacetyl through spontaneous oxidative decarboxylation. As with all chemical reactions, this proceeds more rapidly at higher temperatures. This particular chemical reaction is favored by low pH. In fact, this reaction does not occur when the pH is higher than 4.5. Once diacetyl is formed, it goes back into the cell, where it's reduced to acetoin and 2,3-butanediol. These two compounds will leak out of the cell, but they have very high flavor thresholds and will not be present at the concentrations that are detectable. Diacetyl is also produced when beer becomes contaminated or infected by some beer-spoiling bacteria. The most important factor in controlling diacetyl levels is to have healthy, vital yeast. Healthy yeast can absorb diacetyl 10 times faster than alpha-acetolactate is produced. This means that the reduction of the precursor to diacetyl is generally the rate-limiting step. Reduction of diacetyl also depends on yeast concentration and contact with healthy yeast during fermentation and maturation. Premature or heavy flocculation can result in high levels of diacetyl. It's also imperative that the end of fermentation pH is below 4.5 for these reactions to occur. Brewers can limit the amount of diacetyl precursor produced during fermentation by fermenting at low temperatures. Differences in yeast strains affect overall diacetyl levels that remain after fermentation and maturation, so brewers need to select strains that offer the performance they need to arrive at their target diacetyl levels. The most common method of reducing diacetyl levels in brewing is through a diacetyl rest. In lager fermentation, this means increasing the temperature of fermentation at a point where the fermenting beer has reached roughly half its original gravity. This will speed the conversion of precursor to diacetyl. The yeast can then absorb the diacetyl while there is still sufficient yeast in suspension. In ale fermentations, this means leaving the beer at fermentation temperature until the diacetyl is at its desired level. To know if a diacetyl rest is needed, it's very important to test both diacetyl and precursor at the end of fermentation. Over time, any precursor left in the beer will spontaneously convert to diacetyl. This will be exacerbated by high temperatures and shaking of the beer during storage, during transportation, or by the retailer or the consumer. When sampling beer from the fermenter for sensory evaluation to check for diacetyl or precursor, it's imperative that the beer is heated to roughly 60 degrees Celsius or 140 Fahrenheit in order to force all precursor to be converted to diacetyl, as you cannot taste the precursor. The beer is then cooled and evaluated, and if no diacetyl is perceived, the beer is ready for further processing and packaging. If diacetyl is perceived, it's important to know whether it is diacetyl or a precursor, as the remedy for the two compounds is different. For the diacetyl diagnostic test, we need to draw a sample of beer from the fermenter and remove the yeast by filtering it through filter paper. We then divide the sample into an A sample and a B sample. With sample A, we refrigerate it and taste it. With sample B, we heat it to 60 degrees Celsius for half an hour. We then cool it and then taste it. In evaluating the results, there are three possible outcomes. Situation number 1 has A, the unheated sample, tasting fine, but B, the heated sample, tastes of diacetyl. In this case, there is precursor left in the beer that will be converted to diacetyl over time, and especially accelerated with any exposure to heat. In situation number 2, A, the unheated sample, tastes of diacetyl, and B, the heated sample, also tastes of diacetyl, with the same degree of intensity. That means diacetyl is left in the beer at the end of fermentation. Finally, in situation number 3, A, the unheated sample, tastes slightly of diacetyl, while B, the heated sample, tastes strongly of diacetyl. If B is more intense than A, both diacetyl and precursor are left at the end of fermentation.